Hello, welcome back to Mr. Lamb Science Corner. As announced in a couple of videos, we're doing things a little bit differently now, and we're doing the thing that I thought first that we do this a chat video, and we're going to do elements. And so, what better place to start the list of elements is with number one, and that is, of course, hydrogen. So hydrogen is the name of the element. It has to do with water, as the word hydro indicates. Atomic number is 1, thanks to Henry Moseley, which was the topic of the second video. And the atomic weight, which is an average, is 1.0090. And that is very, very close to 1, which indicates that the other isotopes, that there's one isotope that has just a single proton, no neutrons. And so that's a weight of 1. If you then add in the little bit of deuterium and tritium, then that's going to bump up the average a little bit. It's kind of like somebody gets all D's, yeah, and every once in a while gets a C, and one shining moment he got a B. And who knows what that class was in. But the average is just a little bit above 1. Okay? And it's that of course then makes it the lightest atom and the lightest molecule. And so I promised you that I'd be using atomic notation, and so the simplest hydrogen is going to have a mass number of 1 because it's 1 plus 0, and that has 1 proton. And remember, it's the protons that indicate what element. If you have 2 protons in an atom, you don't have hydrogen. You have helium. And if you change this bottom number, you change the element. It is. The two are very much tied together. The mass number, it can be shared. We'll get up to some elements that the individual isotopes, the mass number is the same as a different atom, but that's because this number is different. Okay, the mass number is the sum of the protons and neutrons, and so when you add in the neutrons, then you have this. But the number of protons is specific to the element. 75% of all atoms in the universe are hydrogen, and most all of those are these. Now, there are some places in older books that will tell you that 90% of the atoms in the universe are hydrogen. We now think differently, and so they bumped up the number of helium atoms, reduced the number of hydrogen atoms. It all has to do with the Big Bang, and that's a whole different topic, and we're not going to talk about that. But you will see in older books, and they don't have to be terribly old. Even in the 60s, they were saying 90% of the atoms are hydrogen. But now they say 75%. So will it change? Probably not. But who knows? I'm not gonna say it can't change, because as they get different information, and the astrophysicists, as they start looking at things, who knows? They might come up with something different. What do we use hydrogen for? Just about everything. There's all kinds of topics we could talk about. I'll just kind of mention them right now. Hydrogen embrittlement. I was watching the TV and a video about a bridge that had collapsed, and it was because of hydrogen embrittlement. Basically, hydrogen is created, well, it's not created. It comes from somewhere else. But we get pure hydrogen, and it seeps into the metal. It actually goes through the metal, and when it does, it weakens the metal. And if it's under a lot of stress, then it can collapse. And so it's a real problem. If you build pipelines of hydrogen, you better line with plastic, because otherwise you're going to have hydrogen embrittlement and you're going to have a collapse of the pipe. One of the big uses that could be, and who knows if it will or not, we have fuel cell technology. And basically you take hydrogen, you put it into the fuel cell, and you get out water and electricity. And the water you can basically just throw away as exhaust. And getting electricity, you can run, say, an electric car, for example. And people are going like, well, wait a minute, I remember the Hindenburg, and they had a lot of problems. Two things you need to know about the Hindenburg. One is 2/3 of the people or thereabouts survived the Hindenburg. You look at that. If you've never seen the video of the film of the Hindenburg, burning, take a look at it. It's on the web. Just type in Hindenburg and see where you'll find it. And it doesn't look like anybody could possibly survive, because it really burns fast. And 2/3 of the people did, because hydrogen, when it burns, the heat goes up real easy, because hydrogen is lighter than air. And so the people who are down here, basically, some of them were burned, but it was a disaster, and a lot of people died, but not everybody died, is what I'm saying. 2/3 of them survived. And so they say, look at the Hindenburg, and because hydrogen burns, the heat goes up very easily, and like this, the fact is people survived. I saw a video 20-30 years ago from Nova, and they were talking about hydrogen cars, and they took a tank of hydrogen that is covered with something that has hydrides in it, basically crumbled up rock that absorbs hydrogen and then releases it. And you can actually store more hydrogen in a tank full of hydride than you can easily store with just pressurized hydrogen. And if you pressurize hydrogen, if you take like let's say a propane tank, and you shoot it, which they did on video from a long distance away, it makes a very spectacular explosion. You shoot a tank of hydride, and you walk up on it, and you hear the gas come out, put your thumb on the hole, and the gas stops coming out. So that part is a lot safer. You take a gasoline tank, set it on fire, it blows up very nicely. You take hydride, you can get it to burn, but if you blow on it, it burns a little bit better. So what I'm saying is that if you have a tank full of hydride, it's very much safer than what we have right now in terms of gasoline cars. The big problem with hydride is that it takes a while to push the hydrogen in. And so whatever range you have the car set to be, if you use the fuel cell technology, you'll go further, but you'll have to fill up eventually, and it'll take you a half hour to an hour to do that. And that's going to be a problem for people. I'm saying when you do refuel, if you got a good range on the thing, you're going to want to stop and eat. And so you pull into a place, you get your car fueling up, go get yourself something to eat. By the time you're through eating, come back, your car is filled up, and then on the road you go. And then another thing that we could use hydrogen for would be, that's a good thing, is people, we take oils and turn them into fats by adding hydrogen to them, and that's how we get margarine, for example. So if you're a margarine eater instead of a butter eater, you're eating added hydrogen. Okay, so there's lots of uses for hydrogen. We can't cover all of them by any means. There's lots of other topics we can talk about, but that's it for hydrogen for now. Thank you very much.